Hello students, in this session
Let us solve a question on principal stresses. In this question, we are given with a carpenter glues a pair of cylindrical wooden logs by bonding their end faces at an angle of 30 degree. Right, this is theta, as shown in fig. Right, theta is given to us 30 degree, and the glue used at the interface fails if the criterion 1, the maximum normal stress exceeds 2.5 megapascal, criterion 2, the maximum shear stress exceeds 1.5 megapascal. If we are applying a uniform tensile stress of 4 megapascal, then we have to find out of these four options which is correct, that whether it fails due to criterion 1 or criterion 2 or both criterion, or it do not fail, right? So basically there is a two logs are there, wooden logs are there, log 1 and log 2, right? And they are joined by glue at the interface like this at an angle of 30 degree with the vertical. This angle is given to us 30 degree. This angle is basically, this is theta, basically theta. This is 30 degree is given to us, right? And a 4 megapascal stress is applied, tensile stress is applied, right? So the log fails according to two criteria. It may fail by maximum normal stresses if normal stress exceeds 2.5 megapascal, or criterion 2 is there, that if maximum shear stress exceeds 1.5 megapascal. So these are the two conditions at which the log can fail at the interface, right? We have to find out whether it fails due to criterion 1 or due to criterion 2, or it fails due to both criterion, or it doesn't fail. This we have to find out. So this question is basically question of principal stresses, which was asked in GATE 2018. Right? So let us solve this problem.
in this question we are given with two wooden logs. This is log 1, this is log 2, and they are glued at this point. This is interface at angle 30 degree to the vertical, right? This is our interface. This is the interface. And when a force is applied, suppose equivalent to 4 megapascal stress is applied to the glued in tensile direction, tensile nature of stress is applied, the failure may take place for the following criterion. One criteria is that if normal stress exceeds 2.5 megapascal, the wooden block will fail, and failure take place at interface, right, where it is glued to each other. And if shear stress exceeds 1.5 megapascal at the interface, then also the failure can take place. Now, if the force or stress 4 megapascal is applied, at what criterion it will fail, whether it fail or not. If it fails, whether it fail through normal stresses or shear stresses, this we have to find out, right? Now, go to the principal stresses chapter. What we have done is, we are given with a stress element. Go to that chapter. Stress element was there. We have taken sigma x in this direction, normal stress, sigma y in y direction, normal stress, and shear stress of this nature. We have taken positive of shear stress of this nature, tau xy, right? And due to this, we have found out the stress at an angle theta, and we have taken theta in our formula with horizontal, right? Here it is given with vertical, theta is given with vertical, right? So, but when we were deriving the formula, we have taken theta with horizontal, and the formula derived came to this conclusion. This was the final formula for normal stress at an angle theta. Here this is the normal stress, sigma n, and shear stress was like this, right? So this was normal stress and this was shear stress. So that was this formula, right? At an angle theta with horizontal. We have taken with horizontal while we were deriving these formulas. So you have to go to principal stress chapter and check the formula. So we can apply directly this formula in this equation at an angle theta. But this angle is with horizontal. This is with vertical. So while using this formula, you have to convert it into the angle with horizontal, right? So what is the angle with horizontal? So actually we are looking for this angle, this angle. So the angle to be used in this formula will be, say it is theta dash. So that will be equal to 90 minus theta. This angle is theta dash, right? So this is 90 minus theta. So this will be 90 minus 30, which is given in the question. So that will be 60 degrees. So we will be using our angle to be 60 degree in this formula, right? And the criterion is given to us. We have to check whether the normal stress exceed this limit or not, and shear stress exceed this limit or not. This we have to check. Now, in this case, what is the stress condition applied? Like sigma x, what is sigma x, what is sigma y, what is tau? So here only one stress is applied, 4 megapascal. Only sigma x is there and no other stress is available here, right? So sigma x is 4 megapascal. Sigma y is 0, no stress in vertical direction, right? And also there is no shear stress applied. So this is also 0. Put these things in this formula and get the answer. So what will be sigma n? Sigma n will be equal to sigma x plus sigma y by 2. Sigma x is 4. So 4 plus 0 by 2 minus sigma x is again 4 minus 0 by 2 cos 60 multiplied by 2 theta. It is 2 theta. 260 theta. I am writing here theta dash. Right? So 2 times 60, this is 120. And minus tau. Tau is 0. So this is 0. Right? Right? Solve it and you will get the normal stress. And the value of normal stress will come out to be 3 megapascal. Right? So the normal stress at this position where there is interface is 3 megapascal, right? It means it fails due to this, because the normal stress should not exceed 2.5 megapascal. So it means it fails at this position. I am making here, suppose this is our interface, this is the interface, and the normal stress here is sigma n, that is 3 megapascal, right? And because this is our interface, and because it should not exceed 2.5 megapascal, so it fails due to normal stresses. First we have checked out, right? So it is greater than, sigma n is greater than sigma max. Sigma n is greater than sigma max, which is 2.5 megapascal. So it fails due to normal stress, right? It fails due to normal stresses. Now next, shear stress. We want to find out the shear stress. What happens with this shear stress, right? Tau is equal to this thing, so we can put the value of tau. So it will come out to be sigma x minus sigma y by 2. So minus sigma x 4. So 4 minus 0 by 2 sine 120 plus tau is 0 cos 120. Solve it and you will get the shear stress, right? It is negative, we can take the magnitude of that shear stress. The magnitude of shear stress will come out to be 1.732 megapascal. I am writing directly the value, you can solve it using calculator. So again, tau is greater than tau max, because tau max was 1.5 megapascal. So here again this exceeds, so it fails due to shear also, right? It can fail due to shear also, right? So it fails due to normal stresses as well as it fails due to shear stresses, right?